I'm going to be explaining exercise 8 from unit 3. Here you have the text. Now that we've seen the text, we can see that we have the probability of the success, which is 0.65. We have the sample size, which is n, and it's equal to 5. And we have the probability of failure, which is 1 minus p, which we already have here, and it's 0.35. So we have here 3 formulas that we can use for this exercise, but we have to see carefully how it says that it's constant. And since it's constant, we know that it's a binomial distribution, so we have to use this formula. Once that we have this data, we just have to plug the numbers in here, and this is our solution. For the second question, we're going to be using the conditional distribution formula. And first of all, we know that it's already bigger or equal than 2, so it's going to be in the denominator. And on top, it asks us the probability of it being equal to 4 or higher than 4. So to know the probability of it being higher than 4 or equal to 4, we do the same thing that we did previously, but this time our R is going to be 4 and 5. So we plug it in the same formula, and this is what we obtain. And the same thing all over again, but this time for it being bigger than 2 or equal to 2. So just probability of it being 2 plus 3 plus 4 plus 5. We plug it into the formula, and this is what we obtain.
Now we're going to explain problem 11. Here you have the text. The following data can be extracted from the text. In the first place, the population size is 50, and then the number of successes in the population is going to be 22, which the opposite will be 50 minus 22, which is 28. The sample size is 5, and then we have P, probability of success, which is 22 divided by 50, which is 0.44. Now in the first section, they ask for the mean, so we just apply the formula that we already know, which is the sample size times the probability of success, and is 2.2. Then they ask for the standard deviation, for which we already have a formula, so we just plugged in all the data that we already have, and we obtain that result. In the second section, they ask for a conditional distribution, so we already know that it must be higher or equal than 1, so we put in the denominator, and we want to know the probability that at least 3 come from this program, so at least 3, which means equal or higher than 3. This is the formula. We plug it in the upper geometric distribution formula, and just to remember, it's important to know that if it's higher or equal than 3, it means the probability of it being like equal to 3, equal to 4, and equal to 5. And then we just plug it in, divide it, and we obtain this result. Here you can see what I just explained. Remember that it's really important that the probability of x being higher or equal than 3 needs to be the sum of all the probabilities when the number is higher than 3. So we just plugged each probability in the formula that corresponds, in this case the hypergeometric one, to obtain the result. And when it comes to the 1, we will need to do it equal to 1, to 2, to 3, to 4, until 5, which is the sample size, to obtain this result. Now we are going to explain the last problem, which is the 22. As we can read on the text, it follows a Poisson distribution, but also we would know that because the Poisson distribution expresses the number of events that occurs in a given space or time, and here they're talking about time. So we could also get that information just by thinking logically. In the first section, they ask for the probability of receiving no call in 1 minute. So no calls means 0. We plugged the data that we have in the Poisson distribution formula, and we obtain that result. Lastly, in section B, they're asking us for the probability of receiving at least 2 calls in a 2-minute period. So since we know that the expected number of successes in a time period is 2, and then we know that the time period is 2 minutes, we just multiply those, obtaining 4, and that's gonna become our new lambda, as we can see. So we just plug all the data again in the formula that, as you can see, since they're asking us for the probability of it being higher or equal than 2, instead of summing up like all of the numbers that are higher than 2, which is impossible to know, we would just do 1 minus the probability of it being 0 and 1. So we just plugged in and we obtained that result.